Hi, everybody, and happy Wednesday. Welcome to tonight's homework help video. We're doing it a little bit different this time, so you're not going to be able to see me, but we're still going to go over homework just like normal. So tonight, we're going to start off on this top section that says, solve each problem below, round each answer to the nearest whole number. Now, we're going to talk a little bit about each of these. So the first question I see here, I noticed that we have subtraction. When we're subtracting two decimal numbers, what I really want you to focus on is the whole numbers. Now notice my whole number in the first number is 43. I'm going to write down 43. And I'm going to subtract away the whole number in the second one, which is 6. It's easier to start with the whole numbers when you're subtracting decimal numbers, because then in the end, I can just go back and add in those decimals. And if the top number, 43, which is larger, doesn't have a decimal, I could just add some zeros there. And then we're just subtracting like normal. So make sure you're starting with the whole numbers when you're subtracting decimal numbers. Now, when we go to multiplying decimal numbers, remember we found it easier to take that decimal out. So when I have this number 3 4/10, if I move that decimal over one time, remember that's the same as multiplying by 10 when we move the decimal over once. In this second number, I'm going to move it over 2 times, which is the same as multiplying by 100, which gives me 725. Remember, multiplying by 100 is the same thing as multiplying by 10 twice. At that point, all I have to do is multiply 725 times 34. And because I multiplied by 10 and then multiplied by 100, I'm going to have to divide by 100 times 10, which is 1,000, which means moving the decimal back 3 times. Now, one thing I do want you to keep in mind is notice this number 3 4/10 is about 3, and 7 25/100 is about 7. So I know my answer is going to be about 21, which would be 3 times 7. So think about that as you're going along too. All right, third question. We have 832 divided by 100. Now remember, we said there's an easy way to divide by tens, hundreds, and thousands, and that's just moving the decimal. Now, first off, I don't see a decimal in this number. Remember, that's because it's a whole number. Whole numbers always have a decimal at the end. So we have 832 divided by 100. When we're dividing, we're moving the decimal to the left, and because we're dividing by 100, we're moving it 2 times to the left, which is the same as dividing by 10 twice, which is going to get us a final answer there of 8 32/100. Remember, really quick when we're multiplying and dividing by tens, hundreds, and thousands. All right. And the last question here is going to be very similar to this multiplication question. I'm going to move that decimal over 2 times, which is going to be the same as multiplying by 100. Which is going to give me 2,268 divided by 7. And basically what I'm going to do there then is just, in the end, do the opposite and divide by 100. And that's going to give me my answer by moving that decimal back 2 times, since I moved it forward 2 times in the first place. So be really careful with those decimal operations, and definitely give it some thought before you're working on it. Think about what kind of answers we should expect. Now, the second part of the directions here says to round your answer to the nearest whole number. So after you get your answer, think about what whole number would be closest, and that's what I'm looking for. What whole number would be closest? All right. Moving on to the next section, we have a number line, and notice our number line doesn't have anything on it, and we're being asked to put these numbers on our number line. Now, I know I'm going to start off at 0, and I'm looking at these numbers, and none of them are bigger than 1 whole, so I'm going to go to 1 whole. I'm going to just add my benchmarks. We have a half, we have a fourth, we have 3/4. Remember, a fourth is the same as 25/100, 3/4 is the same as 75/100, a half is the same as 5/10. Now, this gives me a good place to start. Now, I look at all these numbers, and I'm first starting to think, which ones are more than half? Which ones are less than half? So I'm noticing a couple that stand out. I'm going to work with the decimals first. I'm noticing 9/10. Now, we know that 10/10 would be the same thing as 1 whole. So I know that 9/10 is close to 1 whole. Also, I noticed that 9/10 has a 9 in the tens place, which is bigger than the 7 and 75 hundredths. So I know that 9/10 is going to be pretty close to a whole. One number down. Now, I look at the second decimal here, which is 43 hundredths. Now remember, we could say that 50 hundredths is equivalent to 1/2. So I know that 43 hundredths is going to be less than that, so it's going to be less than a half. But at the same time, it's going to be bigger than 25 hundredths, which then tells me that it's going to be between 1/4 and 1/2, a little closer to a half. So I'm going to put down 43 hundredths, and my second number is down. Now, after you've put all these decimals on the number line, I want you to think about what we know about the fractions. Now, there's two in particular I'm going to give you a hint on, which would be these two right here. Now, when you're looking at 2/5, one thing that might make that easier to put onto the number line is try to change that into a decimal. Remember 2/5, we could change that into another denominator here that could help us to change that into a decimal, since we don't have a fifths place when we're talking about decimals. Now, the other fraction there, 3/12, I want to remind you, we know it's less than half. I want to ask you the question though, is that number closer to being a half, or is it closer to being 0? That's going to give you a really good idea of where 3/12 falls on your number line. So I really want you to think about that. Guys, make sure that you're using your benchmarks, and make sure that you're also really thinking about asking yourself, how do these numbers compare to my benchmarks? All right, that takes us to our last question, which is our word problem. Here's what it says. It says, Maria and Alyssa recently started a business in 5th grade where they make Post-it note art. For the small price of $100, they will create you a beautiful work of art. They named their business the Post-it Girls We Make Art. To start their business, they bought 12 packages of notes for $1.99 each. So 12 packs for $1.99 each. They bought a pack of Sharpies for $21.50. Sharpies for $21.50. And I donated $1,000, so I'm just going to put $1,000 donation. And our question says, how much money will they have left? How much money will they have left? So we know that they bought 12 packs of Post-it notes for $1.99. They then bought Sharpies for $21.50, and we know that they started off with that donation of $1,000, and we're looking for how much they had left. Now, when I'm seeing that, I'm noticing we have that $1.99 that they're going to have to pay for each pack. That word each was pretty important. Each pack, which tells me I'm going to have to multiply that by 12 to get the total for all of the Post-it notes. Now, if I want to know how much they have left, I first need to know how much they spent. So I'm going to have to add that to the cost of the Sharpies. Now, this at this point would tell me how much money that they have spent. I want you to think about how much they started with to figure out how much is left by finding the difference. Think about what operation that would be. Now, when we go back to over here where we found the difference, think about how we started with the whole number and how we used that when finding the difference. And I want you to do the same thing when you are finding the difference over here. All right. Hopefully that helped, guys, and I will see you guys later. Bye. Have a great day.